Okay, we're going to try this again. Number 45. Now, number 45 is going to be a little more complicated than the others because we are going to have the K, and we are going to have to find the concentrations. So we have SO2 plus NO2 goes to equilibrium with SO3 and NO. They give us that the K is 3.75, and I'm going to write out my equilibrium expression as SO3, of course, times our NO. And everybody here is a 1-to-1 mole ratio, so nobody needs to be squared. Now, in this case, they tell us that we initially start off with 0.800 molar of all of the gases. Now, don't let that be confusing to you that you have the same amount of each one. It really doesn't matter. These can be 0. We're going to do the same kinds of things here. They just happen to have it as 0.800. That was the initial. It's then asked us to calculate equilibrium concentration of these gases. We don't know what they're going to be at equilibrium. So we look at the change. Now, whatever the reactants lose, the products gain. So I don't know what that is. I'm going to use X. So my reactants are going to lose X, and my products are going to gain X. And because it's all a 1-to-1 mole ratio, I just have one X for each of those. It's not 2X or anything. So then my equilibrium here is 0.800 minus X, 0.800 minus X, 0.800 plus X, and 0.800 plus X over here. So what I'm going to do then is I'm going to set my K, the 3.75, equal to those into that expression. So I'm going to take my SO3 times my NO, so 0.800 plus X times 0.800 plus X, divided by my reactants, which are 0.800 minus X. And make sure you're watching that properly there. Now what I notice is that these are the same, so I don't have to do any factoring. I can just say that they're squared. This will make the life a little bit easier on this problem. The next problem is going to need to use the quadratic, and hopefully I have enough time on my YouTube video to do that. So I notice the top is a plus X, the bottom is a minus X. I do notice that everything is squared, so I'm just going to go ahead and square root that. If I square root the 3.75, I end up with 1.9365. And then over here I have 0.800 plus X over 0.800 minus X. Okay. Then of course I want to get rid of the fraction here, so I'm going to multiply by 0.800 minus X. Cancels out there. 0.800 minus X. We need to go ahead and distribute this to both of our quantities there. You take the 1.935 times the 0.800, you get 1.549 minus, and again times X, there's 1.9365X equals the 0.800 plus X. So I'm going to combine my like terms. I'm going to go ahead and move this X with this X since it's negative, so it's plus. So I end up with a positive there. Try to make my life a little easier. And I'm going to minus my 0.800. So those cancel out, and these cancel out. So I'm left with over here 0.7492 equals 2.9365X. So of course, to get the X by itself, I'm going to divide by the 2.9365. So then my X, if I divide those out, is 0.255. Now that's my X. If I look, I've got to go back in and plug those in up here. So for both the SO3 and the NO, again, I see that they both started off with 0.800 plus X. So I just need to take that 0.800 plus the 0.255. And of course, why would I write that out? 1.055 molar is, again, the concentrations for both my SO3 and my NO. And then, again, SO2 and NO2 are going to subtract that X. I'm going to pay 0.800 minus the 0.255. You get 0.545 molar is the concentration for your SO2 and your NO2. Okay.